An electric spark is an abrupt electrical discharge that occurs when a sufficiently high electric field creates an ionized, electrically conductive channel through a normally insulating medium, often air or other gases or gas mixtures. The rapid transition from a non-conducting to a conductive state produces a brief emission of light and a sharp crack or snapping sound. A spark is created when the applied electric field exceeds the dielectric breakdown strength of the intervening medium. For air, the breakdown strength is about 30 kV per centimeter at sea level. At the beginning stages, free electrons in the gap are accelerated by the electrical field. As they collide with air molecules, they create additional ions and newly freed electrons which are also accelerated. The exponentially increasing electrons and ions rapidly cause regions of the air in the gap to become electrically conductive in a process called dielectric breakdown. Once the gap breaks down, current flow is limited by the available charge or by the impedance of the external power supply. If the power supply continues to supply current, the spark will evolve into a continuous discharge called an electric arc. An electric spark can also occur within insulating liquids or solids, but the breakdown mechanisms are significantly different than for sparks in gases. Lightning is an example of an electric spark in nature, while electric sparks, large or small, occur in or near many man-made objects, both by design and sometimes by accident. History. Around 600 BC, Greek philosopher Thales of Miletus observed that amber could be electrified when rubbed with a cloth and attract other objects and produce sparks. In 1671, Leibniz discovered that sparks were associated with electrical phenomena. In 1708, Samuel Wall performed experiments with amber rubbed with cloth to produce sparks. In 1752, Thomas François d'Alibard and Benjamin Franklin independently demonstrated that lightning and electricity were equivalent. In Franklin's famous kite experiment, he successfully extracted sparks from a cloud during a thunderstorm. Uses. Ignition sources. Electric sparks are used in spark plugs in gasoline internal combustion engines to ignite fuel and air mixtures. The electric discharge in a spark plug occurs between an insulated central electrode and a grounded terminal on the base of the plug. The voltage for the spark is provided by an ignition coil or magneto that is connected to the spark plug with an insulated wire. Flame igniters use electric sparks to initiate combustion in some furnaces and gas stoves in place of a pilot flame. Auto-reignition is a safety feature that is used in some flame igniters that senses the electrical conductivity of the flame and uses this information to determine whether a burner flame is lit. This information is used to stop an ignition device from sparking after the flame is lit or restart the flame if it goes out. Radio communications. A spark gap transmitter uses an electric spark gap to generate radio frequency electromagnetic radiation that can be used as transmitters for wireless communication. Spark gap transmitters were widely used in the first 3 decades of radio from 1887 to 1916. They were later supplanted by vacuum tube systems and by 1940 were no longer used for communication. The wide use of spark gap transmitters led to the nickname "sparks" for a ship's radio officer. Metalworking. Electric sparks are used in different kinds of metalworking. Electric discharge machining is sometimes called spark machining and uses a spark discharge to remove material from a workpiece. Electrical discharge machining is used for hard metals or those that are difficult to machine with traditional techniques. Spark plasma sintering is a sintering technique that uses a pulsed direct current that passes through a conductive powder in a graphite die. SPS is faster than conventional hot isostatic pressing, where the heat is provided by external heating elements. In welding, a continuous electric spark is created that melts metal and joins 2 parts together. chemical analysis. The light that is produced by electric sparks can be collected and used for a type of spectroscopy called spark emission spectroscopy. A high-energy pulsed laser can be used to produce an electric spark. Laser-induced breakdown spectroscopy is a type of atomic emission spectroscopy that uses a high-pulse energy laser to excite atoms in a sample. LIBS has also been called laser spark spectroscopy. Electric sparks can also be used to create ions for mass spectrometry.